All right, so you have two warm-up questions here. I did forget to mark them as the warm-up, but they are solve each equation by factoring. The first step, we said that we have to have it in standard form with one side equal to 0. So this first one, x squared plus 5x minus 5 equals minus 5. I have to add that 5 to both sides, which it happens to cancel out on both sides. So x squared plus 5x plus 0 equals 0. Now, technically, could you do the x method here? Yes, but if that c value is 0, we really have x squared plus 5x equals 0. And then if we go to the looking for the GCF, they both have an x that we can take out. So I have x times the quantity x plus 5 equals 0. And now I've set my factors equal to 0. I have x equals 0 and x plus 5 equals 0. Same two factors that doing the x method would get you. I just find if you're working with a binomial that this is a little bit easier. X equals 0, there's nothing further I can do to that. So I know one of my places it crosses the x-axis is at the origin at 0, 0. The other one, I'm going to subtract 5 from both sides here and get x equals negative 5. So I have two solutions. So I'm going to put them in my solution set. I have 0 and negative 5. Those are the two spots on the x-axis that my function crosses. That's what that is telling me. Two solutions means that I cross that x-axis 2 times at those values. Again, could you have done the x method? Absolutely. You would have ended up with an a of 1, a b of 5, and a c of 0. 1 times 0 is 0. B is 5. So you would need two numbers that multiply together to make 0 and add up to 5. Well, the only way to make 0 through multiplication is one of your factors has to be 0. And to add up to 5, your other would be 5. So through the x method, you would get the same two factors. But if you look at it as a binomial and take out that GCF, it gets you the same spot. Number 2, m squared plus 6m plus 9 equals 0. Now, the first step is already done. The left-hand side is in standard form. The right-hand side is equal to 0. So I don't have to move anything around. So I can go straight to my GCF. Is there a greatest common factor for m squared plus 6m plus 9? No, there's nothing they all have in common, so there isn't one. So here a equals 1, b equals 6, c equals 9. 1 times 9 is 9, b is 6. So we only have two choices of how to make 9 through multiplication. We either have 1 times 9 or what else? 3 times 3. Which of those adds up to 6? The 3 times 3. So we have 3's on both sides here. Now our a value is 1, so when I divide by 1, it doesn't change my factors. So I have m plus 3 times the quantity m plus 3 equals 0. When both factors are identical, you only have to solve one of them. Because getting two answers that are the same, it's still only one place. So I only have to solve m plus 3 equals 0. Subtract the 3 from both sides. And m equals negative 3. So my solution set only has one value in it. what that tells me, if my solution set only has one value, it's telling me my vertex is on the x-axis. So I could tell you right now my vertex is at -3, 0. Because to have only one solution, that means the vertex is on the x-axis. When I have two, my vertex has to be above or below depending on which way it opens. But when I only have one solution, my vertex is on the x-axis. Now, today you can tell by the title, more solving quadratics by factoring. It's nothing new, same steps that we did yesterday, or actually Monday. But the problems are going to get a little tougher. We're going to get an a value that might be greater than 1. Some of the numbers are a little bit bigger. They're going to take a little bit more time to find those factors. So since we wrote out the full steps yesterday, I'm going to abbreviate those steps here today just to remind us what we're doing. But it's really the same steps we just did on our warm-up. Nothing is changing from that. So step number 1, equation in standard form equal to 0. Second one is check for the GCF. Three, identify A, B, and C. Four, use the X method to find two factors. Five, write out the factored form. And then 6, set factors equal to 0 and solve. Again, same set of steps from yesterday, same set of steps we just applied to our warm-up. The difference is going to be in the numbers we're going to be dealing with today, and we could have an A value greater than 1 today. So we're going to go with the example 3m squared plus 24 equals 17m. So I need to move that 17m over. So I have 3m squared minus 17m plus 24 equals 0. So now that I have it in standard form with one side equal to 0, do I have a GCF here? No, there's nothing that they all have in common. So A is 3, B is negative 17, C is 24. So you can already tell the numbers are getting a little bit bigger today. So we set up our X. What is 3 times 24? 72, and I needed to add up to negative 17. So I need two numbers to multiply together to make 72 and add up to negative 17. And again, if I have a positive product and a negative sum, that means that both factors have to be negative. And I always tell you this, if you know what the two factors are, great. What I'm going to write down now, you could do on your calculator and don't have to write down. I'm just showing you the process I go through. Negative 1 times negative 72 is 72. Negative 1 plus negative 72 is negative 73. Negative 2 times negative 36 is 72. Negative 2 plus negative 36 is negative 38. Negative 3 times negative 24 is 72. Negative 3 plus negative 24 is negative 27. Negative 4 times negative 18 is 72. Negative 4 plus negative 18 is negative 22. 5 does not go into 72. Negative 6 times negative 12 is 72. Negative 6 plus negative 12 is negative 18. So we're getting very close, but that is not the combination. 7 does not go into 72. Negative 8 times negative 9 is 72. Negative 8 plus negative 9 is negative 17. That's the combination that we were looking for. So one side is negative 8, one side is negative 9. We do have an A value of 3 that we need to divide by. I can't simplify negative 8 over 3, but negative 9 over 3 reduces down to negative 3. So my two factors are m minus 8/3 and m minus 3 equals 0. So 3m minus 8 times m minus 3 equals 0. So now I need to take those two factors, set them independently equal to 0, and solve. So 3m minus 8 equals 0 and m minus 3 equals 0. So here I'm going to add 8 to both sides. 3m equals 8. Divide by 3. M equals 8/3. So even though it's a fraction, that is one of my x-intercepts. X-intercepts don't have to be nice, whole, pretty numbers all the time. So one of my x-intercepts is 8/3. The other one, I'm going to add 3 to both sides. And m equals 3. So my solution set is 8/3 and 3. Now, we would keep it as an improper fraction as long as it is reduced to its lowest terms. So that's telling me the two values on the x-axis where my function is crossing. All right, we're going to do a couple more together. I'm not going to lie, number 4, the numbers are a little bit big, but actually I like it because I think this is good for critical thinking and for having to go through the process of finding those factors. This one's going to be a little tougher. I'll be honest, I'm not even going to write out all the factors because you're going to see these numbers are so big I don't have enough room on my paper. But it's still a good practice for us to go through, and we see in something else here that I like that we have to take into consideration. So number 4, 25x squared plus 49 equals 70x. Again, I need to move that over. So I have 25x squared minus 70x plus 49 equals 0. Is there a GCF? No, because 25, the only way to make 25 is 1 times 25 or 5 times 5. 5 doesn't go into 49. So we do not have a GCF. So A equals 25, B equals negative 70, C equals 49. So we set up our X. What is 25 times 49? $1,225. And B is negative 70. So we need two numbers that multiply together to give us 1,225 and add up to negative 70. The only way to have a positive product and a negative sum is both factors are negative. Now again, this is a large product. I'm not going to start, normally I start at 1 times the number. We all know that this is no low numbers because we have to add up to negative 70. And really, there's not a lot of numbers that go into 1,225. You know, early on you have 1, 2 doesn't go in, 3 doesn't go in. I believe 4 went in, but it's still like, it was like 200 and something times. So we know that 4 plus 200 and something isn't going to get us 70. 5 goes in, but again, it's still way too big. And then if you go through your other ones, I don't think another one goes in until 25. I think if you go through and do, you know, 1225 divided by 6, 7, 8, so on and so forth, I don't believe you find another one until 25. At 25, I think it's 25 times 49. So you're getting closer, because what's 25 plus 49? No, plus. 25 plus 49 would give us 74. So we're getting closer to that 70. So we know the number has to be greater than 25. Has anyone found it yet? It's 35. I'll show you something about this problem after we finish it. So both factors are negative 35. So negative 35 times negative 35 gives us 1,225 and adds up to negative 70. Now, we do have our GCF here. that is 25. So we do need to divide by 25. Now, I know that 25 doesn't divide evenly into 35, but it can be reduced. What divides into both 35 and 25 evenly? 5. So both of these can be reduced down to negative 7 over 5. So we have x minus 7/5 times x minus 7/5 equals 0, which is 5x minus 7 times 5x minus 7 equals 0. They're the same factor. I said this earlier today, which means we only have to solve one of them because it's going to give us the same answer. So we solve 5x minus 7 equals 0. Add 7 to both sides. 5x equals 7. Divide both sides by 5. And we get x equals 7/5. So again, we know because we only have one solution that our vertex is on the x-axis. Now, does anybody notice anything about this problem that could have gotten us to 5 and 7 maybe a little bit sooner than we did? Anything you notice about this problem? We talked about this in first semester, but again, because you can use the x method to do this, what is the square root of 25? 5. What is the square root of 49? This is actually a perfect square trinomial. If the first term is squared and the last term is squared, usually the middle term is just the sum of those two. So this is a perfect square trinomial. If you notice that, it could save you a little work. But again, I think that this is a great one for critical thinking and having to go through the steps. And I actually like that once we found the factors and divided by a, we didn't have whole numbers and we had to reduce. That was a good skill for us to have to practice there. So yes, the numbers were a little bit bigger, but it's nothing we can't handle. You guys have the skills and know how to find those factors. All right, number 5, 3a squared equals 4a. So I'm going to subtract that 4a. So we have 3a squared minus 4a equals 0. Do we have a GCF? Yeah, we can take an a out of each term. So we have a times the quantity 3a minus 4 equals 0. We already have our factors without having to go through the whole x method here. We have a equals 0 and 3a minus 4 equals 0. A minus 0 is already solved, so we know our function goes through the origin at 0, 0. We have to find our other intercept, so I'm going to add 4 to both sides. Get 3a equals 4. Divide by 3. And our other x-intercept is going to be at 4/3. So my solution set is 0, 4/3. So again today, same set of steps. It's just really the intensity is increasing because now we have an a value that is greater than 1 that we have to work with. I gave you 8 more problems on the back side for you to complete. And that's what you need to work on.